Okay. Thank you for the opportunity to present here. I'm Theodoros. I'll be discussing design dimensions for blockchain oracles in the, well, that's a typo, in the AEC industry. This is a paper we wrote with Hunhevicz, who presented first today, and Brandon Byers, who could not be here today. And this begins with me saying that I'm really happy that the blockchain papers in EC3 are increasing, right? I'll do a little bit of a shameless self-promotion with the book Blockchain for Construction that came out last year in September. But this also is part of the motivation for the book, because we started seeing certain patterns emerging in terms of design for of blockchain systems in research, and in certain cases also in industry, right? So I won't go too much into, you probably heard a lot of discussion on what exactly does blockchain do, right? What are the kind of problems that blockchain is good for, if you will. And obviously, I'll just try to repeat it very fast, right? We're talking about problems where you have a misalignment of incentives. You might have a problem of trust or security. You might want to use blockchain for automation via smart contracts, as the previous presentation that we saw today. Or you might want to look for governance via multiple parties and kind of secure and guarantee that. But why are we discussing oracles, right? In certain cases, essentially I'll start with what an oracle is, right? So any data source that talks to a blockchain is considered an oracle. And by the very definition, if you look into computer science, it should be trustworthy, if you will. Now, the trouble begins with looking at other blockchain systems where oracles are other software programs. Whereas in AEC and in construction, we have to deal with the physical world in many cases. So an oracle is not just another software or a data stream, but potentially has to interact with the physical world. And this adds a lot of complexity in terms of how we design not the blockchain system itself alone, but also how do we talk to the blockchain so that we make sure our system still sifts trust to the computer protocol, is reliable, is secure, and so on and so forth. So that's the motivation for this paper, because we have noticed a pattern with Jens and Brandon that a lot of papers within the blockchain space essentially focus a lot on the design of the smart contracts and the kind of architecture that the blockchain would have, and there is not a lot of attention in terms of the design dimensions of the oracles themselves, which we think might lead into poor design decisions, because you shift essentially the problem of trust from blockchain itself to the oracle. And this paper is useful essentially on any kind of design of blockchain systems for AEC, both if you're working on industry or if you are a researcher at the moment. And essentially what we did is we looked into the wider blockchain literature, so not only AEC, to find out what kind of taxonomies of oracles people were building, and try to understand what is their nature essentially. And again, we looked into, I can't say it's a complete literature review, right? Probably this will follow, but we looked at indicated papers to find out how we could pick good examples or characteristic examples of how researchers are treating oracles in AEC. And through that, we kind of created a classification, and from also combining our experience, we ended up with the design dimensions of oracles and kind of a sequence that we think every researcher should consider when they're designing one. But also through this, we ended up with following a classification that kind of emerges out of 3 or 4 papers. So essentially, when you're discussing Oracle, you have to consider the data source, you have to consider the trust model, the design pattern in terms of behavior, and then the interaction with the blockchain itself, but also the interaction with humans. So in terms of the data source, This could be software, hardware, human, and in many cases in AEC, it's a combination of all three. For example, a change to a BIM model does take place locally on a software function, but most probably there's a human behind it triggering it. So you need to kind of take into account what kind of data sequences you have and what is the sequence of actions. Then you have a point of the trust model, and we can see here centralized and decentralized kind of ideas. We don't believe that having something centralized is a bad idea per se, right? You don't have to have everything decentralized. Remember, the first blockchain was created as a kind of response to failed institutions, but if your institutions are working correctly, right, they probably provide a very good answer to that part of the trust model. So you have to consider, again, what is the structure there. Then you have the design pattern in terms of how a change to the blockchain is actually triggered, right? Is this taking place through a request response? Do you publish data and someone has to subscribe to that feed? Or is it more of an immediate read kind of situation? And from my experience at least, sometimes it's much more difficult to design the connector software that talks to the blockchain rather than the smart contract itself, which could be really simple internally in terms of its structure and pattern. And then you have the interaction, whether this is something that will stay within the system or go out of it, inbound or outbound, and has implications obviously for human-computer interactions as well. And through that kind of discussion, we ended up essentially with 3 dimensions, right? And these are human versus machine, single versus multiple, and governed versus ungoverned, right? And all of these, of course, act as points in a kind of gradient between those kind of ideas, and we kind of offer them as a very simple indicator of what researchers and blockchain designers could think about. So here in the human versus machine, right, a lot of times we see examples of humans actually issuing data to a blockchain, and there you have obviously a question of whether you have provenance and trust on that data. You have the issue of what is the level of automation, and potentially there you need to incorporate machines. The example here could be, for example, if you're trying to determine what are the weather conditions, you could use a human or you could use a weather station, and it depends on what exactly you're trying to achieve, essentially with reading weather data, for example. And then there is a kind of balance between security and the technology stack on where you might need humans essentially also validating, for example, data or acting as control points in a data stream process. The interface problem becomes much bigger there in the technology stack. And then you have the design choice of whether to use a single data source or multiple data sources. Obviously, you might be able to cross-validate data sources if you have multiple ones. The example we give to the paper comes from another paper from Jens on performance-based smart contracts, where if you have 100 temperature sensors and 98 report, an average temperature, probably that is correct, and you can ignore the 2 that are not within that medium. But also with multiple sources, you can arrive at a good level of decentralization, essentially, and kind of guarantee that you get a system that is less easy to tamper with. Again, if you have a single data source, you need to consider what is the trust that you might have there, because with a single data source, you might get easier attacks on your system, or you might get data failures that are relying on that single source. And I think the most interesting one that we kind of framed in the paper is governed versus ungoverned, right? For us, blockchain is a governance technology, and you need to consider whether you keep your Oracle on or off chain, and then how do you design a system that can validate that data without, avoiding at the same time the problem of having massive data sources going onto the blockchain. And potentially also you can design really elegant systems where you bind governance with incentives, and through that kind of ideas you can increase decentralization, trust, and make sure that your system is resilient. And we have some examples here of essentially decentralized oracles or services of oracles that people could use, or you could design, your own connectors essentially. There aren't a lot of standardization in terms of our work, for example, oracles for BIM or oracles for construction sites, but I think that would be a part of what we will be looking next in this line of work. And thank you for your attention. If you have any questions.